let's continue our study of creating new classes by considering something that's near and dear to my heart, and that's Greyhound adoption. So here's the problem statement. Let's write a program that will improve the way that racing Greyhound rescue groups list their adoptable dogs. This would allow people to search for dogs and refine their search by considering gender, age, whether the dog is good with kids, cats, and small dogs. These are issues that come up particularly with greyhounds. So let's design some test data. Well, we know we're going to need to save and retrieve data on the dogs from a file. And we're going to need to be able to search on each category individually. We're also going to need to be able to refine our search and still have multiple outputs. What this means is that we're going to need to have a lot of data. Now there's a little trick to this, and that's to use the name to summarize the other data elements. This makes it possible to tell if your program's working correctly. So let me show you what I mean in the greyhound.txt file. So here's some sample test data. Notice that as I've done in many of these things, I put the number 8 in first because we have 8 data elements. Here is an entry for a single dog. So here I'm using the name 95FYYY. What that says is the dog was born in 1995, is female, and is safe with kids and cats and small dogs. So now when we list the names out, we'll be able to see if the categories are correct. This is a clever trick for debugging programs. Now I don't really have enough data in here for real debugging of this program. Probably this would be hundreds of items if you wanted to be accurate. Of course, if you were working with a real rescue group, they would have lots and lots of data that you could use, and using their data would be wise. Since our programs are getting larger, we now have more design possibilities to consider. One possibility is what's called top-down. That means you start with the biggest classes first and then move to the smaller classes. So in this case, we would start with the Greyhound rescue group first and then move to the individual greyhounds. Another possibility is what's called bottom-up, and that's where you start with the smallest classes and then move to the larger ones. Now my experience has been that beginning programmers have an easier time with bottom-up design than they do with top-down. And so that's the way that I'm going to work. But remember that both are feasible strategies, and if you're more comfortable working a different way, that's okay too. What isn't okay is programming without doing design first. You always want to think about how you're going to assemble your program, particularly as the programs get larger, rather than just sitting at the keyboard and hacking away at it. In order to teach you how to do design better, I want to introduce you to a cool tool. It's called Umlet. It's an Eclipse plugin that does simple UML designs. It's not the kind of tool a professional would use. A professional would use a more full-featured tool. In fact, many of the professional tools actually keep the design in sync with the code and can write some of the code for you. Not the logic of the code, you still have to write that, but it can write the method signatures and things like that. The problem with those tools is they tend to be expensive, sometimes as much as $5,000 or $10,000 a seat, so we obviously don't use those in the classroom. But Umlet actually does a really good job, and it's a nice, simple tool to use. So that's what we're going to do. Now, if you go to download this yourself, their website is absolutely riddled with advertisements. So download very carefully. A lot of those buttons that say download on the page actually are downloading their advertiser software, not the Umlet software. So read very, very carefully. It is there, it's just kind of hidden. What you're going to need to do is copy the jar file that you download into the Eclipse plugin directory. Now, we haven't been in that directory in a while. The TAs and I can help you if you have trouble with that. The first thing we'll do is create a new diagram. So we go to the File menu, choose New, and then Other and Other again, and it will show an Umlet diagram. So let's do that. Now in Eclipse, we do File, New, Other, and then Other. This normally wouldn't be open. Umlet diagram. Now I'm going to give it a name. I'm going to call it design.uxf. UXF is the extension for Umlet diagrams in Eclipse. And right there we have it. Now what you're seeing here, this is the instructions on how to use Umlet, right here. And then when we scroll down, we have this little area down here. So it looks kind of congested right now, but it's actually pretty simple to use. So for example, to put a class in the diagram, I just double click on it. The things that I enter here are going to appear in this part of the diagram. So I'll show you how that works in a minute. To use Umlet, you select the class diagrams in the upper right area, then you edit the area on the lower right to design the class. Umlet actually shows you examples that help you remember the syntax. The syntax is a little crazy, but it starts to make sense after a while. Now the diagrams will appear in the upper left area, and the relationships get dragged from the upper right area to the diagram. There are two relationships that we've used before. One is aggregation. That's the arrow with the open diamond, and the other is uses, which is the dotted line with the V-shaped arrowhead. So those will be the only two we use. There are lots of other relationships that can occur between classes, and those are what those other arrows are for. As you continue programming, you'll learn how to use those things. The class name is entered first. Minus minus draws the separations. Underscores before and after create underlines for class data and method. Plus means public, just like it does in UML. Minus means private, just like it does in UML. And instance data and methods are not underlined, so you don't put the underscores before and after those. And of course, parameters and return types are entered in text. So we'll do an example in a minute once we have a class to design. So the first thing we need to do is to think about our data a little bit. There's some complications to this data because we're getting closer to real examples. Things tend to get a little bit more complex. So first, let's think about age. Now, you could store the age of the dog, but the problem is that some dogs remain in foster care for a long time. They actually celebrate a birthday in foster care sometime. So a better strategy is to store the birth date, because then you can compare the birth date to the year, and that will give you the age of the dog. That way you don't have to try to update your database of dogs when things are changing. So that's a really good idea. The other thing is that you actually do know in the case of greyhounds what their birth date actually is. It's tattooed inside their ear. It's different for other dogs because most dogs aren't, but with greyhounds, because racing involves betting money, they have to make sure that dogs aren't switched out. So they tattoo them when they're little puppies. It's one of the ways you can tell a racing greyhound from any other greyhound. Now, the gender is also known, and that data is pretty straightforward. We could put it in a Boolean because they are either male or female, and that's two choices. But we're just going to use a string for that. And then there are three other descriptors that we have to worry about. And that's whether they're good with kids, whether they're good with cats, and good with small dogs. These are things that most greyhounds are, but some greyhounds aren't. For example, my racing greyhound is not good with cats, so she couldn't go to a home that has cats. Absolutely not. Luckily, I don't have cats, so everything's okay. Now, there's a challenge with making these things Boolean, and that's the fact that they can be unknown. So, for example, when a dog comes right off the track, they may have no idea if it's good with kids or cats or small dogs. And there may be a period of time before the adoption agency is able to discover that information. So we actually need 3 categories, not 2. And there is no primitive data type in Java that holds 3 categories. So let's think about how we could make one. What we need is something that's called an enumerated type. So we need a choice for yes, we need a choice for no, and we need a choice for unknown. Now this is a new Java trick that you probably haven't seen before, but it's kind of cool. We could make these integer constants, and that would be one way to do it. But since there is this neat Java thing and we're getting towards the end of the semester, I really want you to see it. So it's a Java shortcut. It's called enumerated type. If you've been paying attention in Eclipse, you probably realize that Eclipse has some support for this. Even though we don't know how to use it now, we can learn. So what it basically does is creates constants for you and sets them to integer values. You can use the integers just the way you normally would. You can do equality comparisons with equals equals, and they have lots of other cool features in Java. Now, I'm not going to show some of the really cool stuff, but if you're interested in continuing your study of Java, look up enumerated type in Java online and you'll find lots of really interesting things they can do. Here's the design. We need a variable with 3 constants for yes, no, and unknown. So this is essentially what we need. Now I'm showing this diagram in UML, and that's what we're going to try to recreate inside of Umlet. So I called the name of the class YNU for yes, no, unknown. It's not the class name that I'm the proudest of that I've ever written, but it'll do for now. And we need 3 constants. Now notice those constants are underlined. The reason they're underlined is they're class data. Now there is no way in UML to say that something is a constant. So the underlining in the all caps is a way of communicating to other people that you anticipate it being a constant. But it's really a code convention. It's not necessarily a design matter. Nonetheless, we'd like to do it that way. Let's go and take a look and draw this diagram in Eclipse. So instead of simple class, we're going to call it YNU. Notice that's put the class name centered at the top, just like it's supposed to in UML. Next, we need to draw a line. Remember, we do that by putting 2 minus signs there. One thing that's neat here is notice that even if I resize this, the line goes with it. So actually, it's kind of a nice little user interface. Now we're going to need our data. Because it's class data, remember it starts with an underscore. So we have yes and another underscore. Now I didn't put in modifier there, so we need to think about that. Should this be public? Should it be private? Well, we're creating this to use in another class, so that means it should be public. And public starts with a plus. Now we'll do the same thing for no. And the same thing for unknown. So there we have it. Now this doesn't have any methods. And remember in UML, when you don't have any methods, you don't have to have that 3rd section below it. So this is the only thing that's going to be in our class. And right there it is. Notice, actually a lot easier than working with a word processor and trying to do a design that way. This is one of the reasons that I've now integrated Umlet into all of my classes. So the last thing we want to do is to actually implement the class. Now you're going to be amazed at how easy this is. The implementation is actually only 1 line. So here we are in Eclipse. And notice keeping the design as part of the Eclipse package also means that other people who might read your code will have access to it. It's much easier to read designs than it is to read code. Maybe not at first, but as you become a more experienced programmer. And so this is a nice way of communicating to other people how your program is put together. So we're going to do File, New. Now, if you look down, you'll see we have enum here, and that's what we're doing. So we'll create a new enumerated type, and we called it YNU, and then we'll finish. So Java has done almost all of the work for us. The only thing we have to do is to put in yes, no, and unknown, and a semicolon. And everything's done. Easiest class we've ever written. Everything is public automatically because that's what makes sense in an enumerated type. Now the other thing we could do is we could do some documentation, particularly because our class name isn't very good here. This is a good time to put in some Java doc. So let's do that. So it's an enumerated type that keeps track of data that is almost Boolean, but could be unknown. And for some reason, Eclipse always likes to mess up my name. So let's fix that. And of course, this is version 1.0. But this is very likely to be the only version that ever exists of this class because the class is so simple, it's a little hard to know what would need to change. Now it's time to think about the Greyhound class. This class is a composition of the basic data about an individual dog. This is what it would look like. The name of the class is Greyhound. We've got the name, we've got the birth year, and we've got cat safe, kid safe, and small dog safe that are all of type YNU. So notice we have a relationship between the Greyhound class and the YNU class. The YNU class is used in the Greyhound class. Now this is actually not an aggregation relationship because the YNU class is sort of like a primitive data type. It's a very, very simple class. It's not like part and parcel or a whole element of it. And so that's not an aggregation relationship, that's a uses relationship. Now we're going to need some accessors too. So those will be things that look like get name, string. I didn't put those in the PowerPoint because you run out of space in PowerPoint, but we will put them in our design. We might want to think about whether we need mutators or not. Remember the purpose of the program. We're just trying to let people search these dogs. We're not adding new dogs or deleting dogs or things like that. Presumably that's being done by some other piece of software or in some other method. So since we don't need them, we're not going to put them in. This means that our Greyhound class will be an immutable class. Now that could be good, that could be bad, just depending on how things work out. Maybe later on we'll have to add mutators in. But it's a good place to start to not put mutators there. When you don't have mutators, you know the data you construct remains pure and remains safe, and so that's a good thing. So let's go and create our design first, and then go and take a look inside the class. So returning to our design, we're going to add another class. Now unfortunately it always sets it right on top of that one. But hey, it's free software. You going to complain? So this class is called Greyhound. And remember, we use 2 minus signs to get the separation between the class name and the data. Our data elements were a name, that's a string. Now this box is a little bit small for our class at this point, so let's drag it and make it bigger. Then we're going to have a year of birth. If we were writing this as commercial software, we'd probably put a day of birth, so we could calculate the age more correctly. But this keeps our software a little simpler, so let's do that. Next we have 3 fields, one for being kid safe, and this is of type YNU, for yes, no, and unknown. We also have cat safe, YNU, and of course, small dog safe. So now we have a relationship between our 2 classes that we need to record in the UML diagram. It's a uses relationship, not an aggregation one, and so we need to pick the right kind of arrow. If we scroll over here, we'll see a lot of our options. So we're looking for a dotted arrow with a V head. So that's this arrow right here. Notice that this one has a different kind of head. It has a triangle head. That arrow means something different. It's very important to get the right symbols in these places, and you'll learn the difference between them as you become a more experienced programmer. So we now take this and drag it over here. There we go. Now, the head of the arrow belongs at the YNU class, and the tail of the arrow belongs at the Greyhound class. And we might make it flat to make it prettier. So right there we have it. Now, we can put some other things on this arrow, but there's really nothing else needed. So let's just leave it as it is. Now we go back to our Greyhound class. We've got our data summarized, and the next thing we need are our accessors. So we need another separator, 2 minus signs, and then we're going to need an accessor for each one of these fields. So by convention, we call the accessors get and then whatever the data field is. So for example, get name will return a string. Now we do have a different case here with year of birth because we want to do things by age. So we're storing it by year of birth for our convenience, but the person who's using this class is probably only interested in the age. So we're going to create an accessor called getAge. And that, of course, will return an int. Here are our other accessors. Get kid safe. That's going to return a YNU. We'll have get cat safe, and that's also going to return a YNU, and get small dog safe, and that will return a YNU. By convention, we don't usually put constructors in UML, but it's not a bad idea to do it. Even though it's not sort of part of the official UML rulebook, my experience has been that when I put the constructors in UML, my students do a better job of remembering that they need to have a constructor. So let's put them there. So this will be Greyhound. Of course, constructors are almost always going to be public. I can think of maybe only 2 exceptions to that in many years of programming. So we're going to need a name that's a string. We're going to need a year of birth. That's an int. We're going to need an indication of whether the dog is kid safe. So that's a YNU. Cat safe is another YNU. And small dog safe. When we look at this on the screen, it's going to have gotten long and ugly. So notice now, to get all of it, we would have to go over more than the screen. I'm going to just stop there because our screen real estate is in pretty short supply. Let's get our YNU class out of the way. So I'm moving it under those other diagrams. We might think about whether there is another constructor that we would like to have. Now, from my experiences with Greyhound Rescue, I know that there's another constructor we need, and that's one that just has a name and a year of birth. The reason that's important is that almost always when a new dog arrives, they know nothing about it. They have no idea what it's like. And so you want them to be able to include those dogs too. Since for a lot of people, kid safe and cat safe and small dog safe don't matter. A lot of Greyhound Rescue people only have greyhounds, and so those things are irrelevant. So let's create a second constructor. As always, the name of a constructor is the name of the class, and this will have a name and a year of birth, and that's an int, and only those 2 fields. So there's a great second constructor. Now, if we were going to put mutators, we could put them in next, but we decided not to do mutators. Let's go and take a look at our Greyhound class. So you'll notice that I imported the Gregorian calendar class. That's because we're going to have to do a calculation of a birth date. And here's our data. Now this is all private data and instance data. The reason it's instance data is because these values are different for every single individual dog. That's what instance data is. There's our constructor, which is now spelled correctly. And of course, it's JavaDocked. So let's actually implement this constructor next. We need to make sure that every single field is correctly initialized. That is the critical responsibility of every constructor. The name will be name. Now, if you look at that line of code, you know something has to be wrong with it. It doesn't make sense to say, take the value in name and store it in the location name. Doesn't make sense at all. The thing is, the name that I have on the right-hand side, I really mean the parameter, and the name on the left-hand side, I mean the instance data. Now, there are a couple of different ways we could fix this. We could change the parameters so they didn't have the same name as the instance data, but there's another quick fix available. And that's to specifically say that it's instance data. So you do that by putting this and a period in front of it. So let's do that for all of our data. Notice we're dealing with the YNU data exactly the same way we would with any other data. We're just copying the values over. Okay, so now Eclipse is happy. Let's make sure our second constructor is there. Oh, it looks like I haven't implemented that one yet. So the easiest way to implement the second constructor is by copying the first constructor. So there's a Java trick for that. What we do is this. We say the name is name, and here we mean the parameter name, and then the birth year and the sex. Our other constructor has 3 more parameters, and so we need to put in what those 3 arguments are. Well, they're unknown. So the way we say that is YNU, period, unknown. YNU, period, unknown, and YNU, period, unknown. The reason we have to have Y and U in front of it is that without that, Java wouldn't know where to go and look for the constants. So that's a necessary part. And of course, as always, end with a semicolon. Now this is a really nice way to write constructors because it means there's one constructor that's doing the heavy lifting and all the other constructors rely on it. So for example, if we wanted to do some error checking later on, for example, maybe to check that the sex that they're putting in is either male or female, always a good idea to check those things, then we would only have to change the one constructor and all the other constructors would be updated automatically. So that's a nice way to do things. So we've implemented the constructors. I left two other methods to be implemented just so you get the flavor of implementing a class. One will be getName and the other will be getAge. Here's the getName method. I've left it as a stub right now, so it's return null. So what we need to do is return the dog's name. And that's just written return name. Very simple code to write. People always like writing accessors. Now the getAge is a little bit more complicated because we're going to have to deal with what today's date is and the date of birth for the dog. Now we did this back in the semester, but you may not remember all the details. Basically, we created a Gregorian calendar object called today. The default constructor creates a date for today, and then we use the get method to get the year. So here we go. We have a Gregorian calendar object, which I'm calling today, and constructing it as a new Gregorian calendar. Then we have our year will be today.get, and it's Gregorian calendar dot year. Year in all caps because it's a constant. And then what we're going to return is this year minus the birth year. You might ask yourself, isn't that a little inexact? Well, yes, it is. So for example, if the dog is born on January 1st of 2013, this would say that on December 31st of 2014 that the dog is only 1 year old. But you know, it's fine. We could do a more refined version later considering the month and the days and things like that. But let's move on to some other more important programming problems. So you'll notice we still have a little red X at the top of the class. That's because this file hasn't been saved. Uh-oh, Eclipse is still unhappy. So let's see what happened here. Well, it's complaining about YNU.unknown. So let's take a look and see what's wrong with that class. Well, we've got YNU.unknown. But here's the problem. Notice YNU hasn't been saved yet. You can see that from the little asterisk in front of the class name. Things like this are going to start mattering at this point, and so we need to pay attention to them. That's why the Greyhound class is having trouble finding unknown, is the file hasn't been saved since unknown was added to it. So let's save the file. And then go back to our Greyhound class. And notice now, no little red X. Everybody's happy. Now the next thing we need to consider is the next larger class. So this is going to be the whole Greyhound rescue organization. So the data for that is going to be a list of greyhounds. Well, you're probably guessing already that we could have an array or we could have an array list. Because we don't know the number of greyhounds that are going to be there at any one time, it makes more sense to have an array list here. The other thing we're going to need is a default file name. Now we've used that trick many times, so it won't surprise you a bit. We're going to need to have the search methods for each of the 5 fields. So that's going to look like something like get dogs by age. If you think about it, what you're going to need to be able to do that, our parameters, would be the minimum age and the maximum age. So give people a range they might consider. And the return type will be an array list of greyhounds. So we have an array list of greyhounds that's saved as the instance data in the Greyhound Rescue. So this software actually could be used by multiple different Greyhound rescue organizations. It's always nice to do things that way because it makes your software more marketable. So let's go and write the UML. So I'm headed back to Eclipse and to my design. So let's move to some new space. Well, we better create our class first. This is much easier to do on a larger screen. So here's our simple class. We're going to drag this down and then move down. Give ourselves some space. It's probably wise to leave a little bit more space between this new class and our Greyhound class, because we know that our Greyhound class has a relationship with this class. We'll talk about what that relationship is in a minute. We're going to have Greyhound Rescue. That's the name of the class. Draw our little line, and we're going to have a variable which I'll call adoptable dogs, and it's going to be an array list of Greyhound. We're also going to have a file name. Now you might think about it, should the file name be class data or instance data? Well, the file name is a constant because it's a default file name, so that should be class data. So that one's going to start with an underscore. I'm putting it in all caps to indicate that it's a constant, and let's call it greyhounds.txt. Now I'm kind of cheating with UML a little bit here because you're not actually allowed to put the values of constants in there. And following the rules is important, but so is clear communication. So I'm erring on the side of clear communication and cheating a little bit with UML. That's our instance data. Now, if we think about it, we're going to need a constructor. Remember, constructors don't have return types, so don't put a return type in the UML. We're also going to need to read the data from a file. Now, we could pass in a string file name if we want. We could use the default file name, probably an easier choice. Now, in this case, we are not going to return an array list of Greyhounds, because when we're reading the data from a file, we're using it to initialize the adoptable dogs. That's instance data for the class, so we'd want to have a void return type. In other words, we're putting the data in this particular object, not returning it to somebody else. And of course, we're going to probably want to write the data to a file eventually. Now, we might think about whether this method is really necessary right now because we're not changing the data. So since we're not changing the data, we know we're not because we don't have any mutator methods hanging around, this method actually could wait. I'll leave it in the UML because it's something that will need to be done eventually. Now let's write a search method. So we're going to do get dogs by age, and we'll have the minimum age, which should be an integer, and the maximum age, also an integer. And this is going to return an array list of Greyhound objects. So basically, it's going to look through all of the dogs that are in our list of adoptable dogs and find the ones that meet the criterion. Now, there are going to be a lot of different methods like that. In fact, there will be 5 of them, one for each of the 5 fields. I'm not going to put those in the UML right now just to save us a little bit of time. Let's think a minute about the relationship between the Greyhound Rescue class and the Greyhound class. Is that a uses relationship or is that an aggregation relationship? Well, this is different than the YNU class. The YNU class, remember, was very much like a primitive data type, sort of like a Boolean on steroids. But this is a deeper relationship. The parts within the Greyhound Rescue class of the data are actually Greyhound objects. This is an example of aggregation. So we're going to need to use our symbol for aggregation. So we're going to go over here and look down at the various type of arrows that are available. And right there is our arrow that means aggregation. So we'll bring this one out here. Now in this case, the diamond goes towards the class that contains the objects, and the flat end goes towards the other class. So there we go. That's showing the correct relationship between our classes. Notice we're communicating some very powerful and profound things about the software very simply in the diagrams. It makes it so much easier to implement the classes when you have these designs available. So even though it's kind of hard to write the designs at first, this is a skill that's very much worth developing. Okay, so let's go to the implementation now. The first thing we'll do is the constructor. Then I'm going to do an instance method called search by age. The other search methods are virtually identical. They just have a little different test in the middle, so I'm not going to show all of those in the interest of saving us some time. So now we're in the Greyhound Rescue class. So let's take a look around. Of course, I've Java docked it for you. Here is our instance data right here. So notice we've got a private array list of adoptable dogs, and we've got our constant that's the file name for greyhounds.txt. Here's our constructor. The goal of the constructor is to make sure that every single instance data is valid. So we need to create an array list. So here we go. Adoptable dogs equals new array list of Greyhound, and open and close parentheses. Now there is no other instance data. Remember, the array list keeps track of a lot of things like the size itself, so we don't have to put those things in our class. That's one of the advantages of using it. Here's the read from file method. We've written a lot of those methods, so I'm not going to review that one very carefully. There's write to file. Here is our get dogs by age. We need to think through how we're going to do this. We're going to step through the list of available dogs one at a time, figure out if this dog is in the desired age range, and if so, add it to the return list. So there we have some guidelines for how we're going to do it. We see we're going to return an array list of Greyhound, so we need to construct that. So here's array list of Greyhound, and I'll call it result, and of course we need to call its constructor. If you forget to call the constructor, you'll get null pointer exceptions, remember? So null pointer exception is almost always a mistake in forgetting construction. And we know at the end we're going to return that list. So that'll get the compiler off our back and get rid of some of those annoying little red X's. Now we're stepping through the list of available dogs one at a time. That's a for loop. So let's create an index which starts at 0, and it's going to stop at adoptabledogs.size and be incremented by 1 every time. Now those two steps have to be done for every dog. So they're going to be inside the list. So I've indented them a little bit. So now we need to figure out if the dog is in the desired age range. There are a couple of different ways to do this. You can pack it all into one statement, but the syntax gets very confusing. So what I'm going to show you is a method that I've found to be much more foolproof for beginners. We're going to make sure we understand the type of every single data element one at a time. So first we're going to have a Greyhound object, which I'll call this hound. So that's going to equal adoptabledogs.get of index. So that reminds us that when we get something out of an array list of Greyhounds, it is a Greyhound. Once you know it's a Greyhound, you know what kind of methods are available. They're the ones in the Greyhound class. This avoids a lot of confusion. So now we'll do age is this hound dot get age. We know that that's okay because we know that Greyhound objects have an age. Now apparently I've forgotten the name of our method, so let's go to the Greyhound class and take a look at what the method is actually called. We could also do this in the Package Explorer if we wanted. So the method is called getAge. I wonder what it didn't like. Let's go and take another look at our code. Oh, well, that's what it didn't like. Notice I forgot a word. I put this here instead of this hound. Well, this is a type Greyhound rescue, and it doesn't have a getAge method. So in this case, Eclipse was exactly right. Now, this also suggests that maybe I didn't choose that variable name too well, so let's fix that. Let's just call this hound instead of this hound. That will avoid that problem in the future. It's also shorter and it makes the code better, so those are good things. So now we need to do our test. Well, if the age is greater than or equal to the minimum age, and the age is less than or equal to the maximum age, then what we want to do is add this hound to our result list. So that will be result.add of hound. Now, one thing we might want to think through, whenever we have a greater than or equal to or a less than equal to, we think about whether that equality is the right thing or not. Well, as a rescue person, you want to give people the maximum number of choices they possibly have. So including the equal sign there includes the dogs that are on the edges of their age range. So that's probably the right thing to do. Notice we're breaking one of our Java idioms. Usually when you have a minimum and a maximum, the minimum is included and the maximum isn't. But in this case, as long as we document it properly, we're going to be okay. Remember, we're interacting with users, and they don't think in terms of weird Java idioms. Another thing as a rescue person is sometimes people are reluctant to adopt older dogs, so you certainly don't want to be excluding them from the search because they are some of the harder dogs to adopt anyways. So compassion indicates there should be a less than or equal to and a greater than or equal to there, in addition to common sense and correct programming. Now the rescue interface is some more interesting code. It's going to use the Greyhound rescue class. Notice use, not aggregate. Here's what we're going to do. We're going to loop until we quit. Choose either a new search or a refined search. Now that's interesting. That's something we haven't done before. We're going to choose the field to be searched. We're going to get the data for the fields that need data. Then we're going to perform the proper search, and we're going to report the results to the user. Now everything here is something you've done before except for this refined search. So let's talk about that one a little bit. Here's how you refine a search. The original search will save its results to a local variable in the RescueInterface class. So that will be an array list of greyhounds. Notice this array list is different than the list of adoptable dogs that's available in the Greyhound rescue object. This one is just some temporary results. In other words, to put it in more mathematical terms, it's a subset of the list. If the search is later refined, this list needs to be searched instead of the list in the Greyhound rescue object. So at that point, we don't want to be using the instance data in the Greyhound rescue object. We need to use the local variable. Well, if you're not using the instance data in the Greyhound rescue object, guess what? That's a static method. So if you've wondered what the difference is between instance data and class data, well, you're going to see a perfect example here of how this works. We're not using the data in the class, and that means we're going to need 5 additional static methods to make this refining the search work. Now, obviously, I'm not going to implement all of these for you right now, but I do want to implement one. So let's go to the Greyhound rescue class and take a look at what one of these static methods will look like. So here's our Greyhound rescue class. Now this is the instance method that we just finished writing. Right below it, I left a stub for a static method. So first off, let's look at how the signature is different. Notice now we have an array list of greyhounds that's passed in to a parameter. That's necessary because we're not using the adoptable dog list anymore. We're using the subset that came from the prior search. Since we're not using adoptable dog, that means we put static here. So when we call this now, we'll call it by Greyhound rescue period get dogs by age, instead of calling it from the object. I'm going to cut and paste the previous method because it's very similar, and we'll just make the minor changes that are necessary. Here's the first method. Now we scroll down. We can remove our stub and paste. So let's step through the code one piece at a time. You'll notice that Eclipse is actually helping us out. Notice how adoptable dogs is now underlined. The reason that's underlined is that adoptable dogs is instance data. We're in a static method. That is a class method. We don't have any access to our instance data. And so that's not legal there. So actually, this is telling us a good map of what we need to do. We're still going to need a result array, so line 109 won't be changed. We're still going to need to step through a list of dogs, but it's a different list now. Now we need to use hounds, the one that's coming from the parameter, not the instance data, because in a class method you don't have access to the instance data. So there we go. Again, instead of using adoptable dogs here, we'll use hounds. Now notice Eclipse is happy at this point, but it probably still pays dividends to go through and read the code carefully. So we get the age. We see if the age is bigger than the minimum age and less than or equal to the maximum age. If so, we add it to our result, and at the end we return our result. So this is the difference between an instance and class method. A very valuable lesson to learn. Now you probably noticed that in this presentation that I've done a lot less implementing of code, although I did implement quite a bit of code before it started. Instead, we focused our efforts on design. The design work is really the important part of the work. As you go on, the implementation tends to get easier and easier, and the design work tends to get more challenging. As the designs become more elegant, though, the implementation generally becomes more simple. So when you have a class that you're having a difficult time implementing, often it's because the design is wrong, more than that the code is wrong. So just as with methods, small classes are generally better than large classes. And again, making classes too large is a mistake that beginners tend to make. So keep programming.